it's getting late, so hopefully I can still make sense here. I've been filming quite a few videos for you guys, but I was grading some of your stuff. This is Wednesday night, grading some of your guys' books from last week when you were working on second part of Module 2. And there was one problem where some of you got it right, but I wasn't 100% sure you had the whole entire process down. Like some of the numbers were in the right place, and I know like Caitlin and Abby are getting some help from. Is it your grandma or your grandpa? I thought your mom said it was your grandpa. And I'm wondering if maybe you were like kind of trying to understand what they were saying and writing it down, but you may have it down pat. I'm not trying to like throw you under the bus. But just from what you wrote down, I was wondering if you fully did. And I haven't graded everybody's stuff, but I think probably universally there's a good chance some people are having problems with this. So I wanted to talk about it. It's when we have a certain chemical reaction, and we have two things reacting, and we get some new substance and some leftover stuff. So we have to figure out how much of the whatever that item is, how much do we actually use since there was some leftover? So how much do we need to actually react fully? And then let's say we want to make a greater amount than what we got. How do we figure out how much do we need of each of those substances that we started with? So let's put some actual words behind all those things. So we'll do number 5. It's on page 63 in your workbook. So if you had a hard time with that, I would encourage you to take a look at this. So I'm going to kind of try and block my face out and just write. I'm trying to get situated so I can write without actually worrying about where the whiteboard is at. So they say, number 5, in making calcium nitride, does anybody remember how to write that? It should just be Ca calcium nitride, okay? Two nonmetals, right? Am I getting confused? No, sorry, not two nonmetals. Two nonmetals are covalent and can come together different ways. So no, we can name it that way because it's a nonmetal and a metal. Sorry. It's late, my brain's a little tired. Okay, so we have calcium nitride, and it tells us that we, in making calcium nitride, 100 grams of calcium, so let's just write this down, 100 grams of calcium plus 100 grams of nitrogen gives us 152.5 grams of product, basically calcium nitride, that was the product, plus some leftover nitrogen. Some amount of nitrogen left over, okay? So the first thing, so then they say, how much nitrogen and calcium should be added together to make 1 kilogram or 1,000 grams of calcium nitride without any leftovers? So if we don't want any leftovers, we want to find out what amount needs to react exactly together to give us no leftovers. So what we can first need to find out is how much nitrogen is left over. So how do we do that? We need to take our law of mass conservation. If I have 200 grams over here that I started with, I need to end up with 200 grams. So this is just basic subtraction. If I need 200 grams over here and I have 152.5, first step is I'm going to say 200 grams minus 152 grams equals, what does that equal? Sorry, all of a sudden I thought I kept somebody else's book for a second. Where's it at? It's 52.5, right? No. 47.5. So that's 47, follow my own work, 40.7.5 grams of nitrogen. Okay, so that's how I figure that out. That's how much nitrogen is left over. Okay, step number 2. If I know that I had that much left over and I used 100 grams, I'm going to say 100 grams of nitrogen. And I would encourage you to use units so you remember what you're talking about. And I would encourage you to kind of do this step by step instead of like all over the place, which I sometimes have a habit of too, but if you can do it step by step, it helps me to follow what you were thinking and what you were doing each step of the way so that I can follow your thought process. So I'm going to take 100 grams of nitrogen that I started with and subtract the leftover stuff, and that gives me, I believe, 52.5 grams of nitrogen is what I actually used. So 100 grams of calcium reacted with 52.5 grams of nitrogen to give me 152.5 grams of calcium nitride, okay? So then the question is, well, how much of each of those do I need if I want to make 1,000 grams or 1 kilogram of calcium nitride? There's 2 different ways to do this, okay? Let's do it the way the book does it. I'm going to try to remember how I did it here. I like my way, but I have to think about what I did. I've been working on the book's way today a lot. Okay, so basically I'm saying that trying to find what factor it got multiplied by. It'd almost be like looking at like a cake recipe and just saying, if I want to make, it's easier when I'm thinking about a cake because I would just say, if I want to make 5 cakes, I need to multiply everything by a factor of 5. So if I used 1 cup, I use 5 cups. If I use 2 cups, I use 10 cups. But in this case, it's not as simple because it could be like a decimal. So I'm basically saying that if I have, make sure I'm saying this the right way because I'm looking at my own work and I did it differently. I'm saying that my 152.5 grams, what is that getting multiplied by? What factor is it getting multiplied by to equal 1,000 grams? And here's where you need to be careful. They ask you to find 1.0 kilograms, but look, this is already in grams, so I can't just put in 1.0 kg over here. I have to get this into grams, so make sure that you pay attention to that, or I have to turn this into kilograms. I gotta do one or the other so they match. So I'm saying, what amount is this getting multiplied? When I talked about the cake, I'm saying I want to multiply it by a factor of 5. But I could say you could do it by weight. If one cake weighed this much and then I had the weight of 5 cakes. It's harder because it's easier to identify 5 cakes. But if you're just looking at the weight of 5 cakes and said what factor did it multiply by, I can do it this way. Sorry, my cake analogy is not holding steady very well. Maybe it's helping you. I don't know. So what factor is this multiplied by to get 1,000 grams? Okay, well, how do I solve for that? I just divide both sides by 152.5, divide by 152.5. Hopefully, that part isn't confusing to you, just the basic algebra. And that gives me, I believe, if I remember correctly, 6.6. And I think, be careful here. I'm going to just go with 6.6. So let's start. Let me write this out right here. So third step is I'm saying 152.5 grams times some factor needs to equal 1,000 grams. Did you notice when I solve for that, I'm dividing by 152.5 grams on this side and this side. So those cancel out and I get x. And then my grams also cancel out here and I get my number. So x is going to equal, I believe, like, here, let me just calculate it. I believe it's just 6.6. One thing I think the book does that's a little confusing is they take, I need to find a calculator here, significant figures like as they go, and that isn't typical. You shouldn't really take, here's my calculator on here. You really shouldn't be taking significant figures until the very end. There it is. So, yeah, don't take significant figures until the end. So 100 divided by 152 point, not 100, did I just say 100? That's what happens when I do things late at night. Divided by 152.5 gives me, oh goodness gracious, I did not do that right. Give me a really small number. Divided by 152.5 equals, yeah, actually it comes out to 6.57. Let's just keep it at 6.557, okay? Because the next number is a 3, so that would stay 7, just to keep some decimal places there. What would my significant figures be here? Let's see, it was 100.0. My smallest significant figures are 2, the 1.0 kilograms, so I can only have 2 significant figures. Just don't take it yet, okay? You don't have to, so don't do it till the very end. So this tells me that each of these things have to be multiplied by a factor of 6.557. So I know it was 100 grams of calcium that got reacted each time. So 100 grams of calcium, times the 6.557 is going to give me an amount of calcium. And then remember, it wasn't 100 grams of nitrogen that reacted, right? It was 52.5 grams. So that 52.5 grams of nitrogen is going to get multiplied by a factor of 6.557 as well. Okay? So then my first answer should be, this is multiplied by 100, so this is just going to move over, right, to 655.7 And then this one is going to be, we'll do significant figures in just a second. 52.5. Sometimes I like to address significant figures as just my final step. So I don't forget it. So it's like part of my process. And then this is going to equal, can you see? Oh, sorry, I was kind of tilting that back. I'm sorry. I know this is small and not super ideal. Wish I had like that board like Sal Khan on Khan Academy has, where you can like write and you can see. I don't know how he does that. Does anybody know? Because that would be so spectacular. I'm sure it takes technology. Something I don't have, but it would be great if I did. Maybe he just does it on the screen. Oh, he probably does, doesn't he? With like a, what do you call it? The thing you can write on the screen. I'm thinking what they're called right this second. And then does the screen recording. That's probably what he does, right? Maybe I could do that on my iPad. If I had a stylus, oh, that'd be so cool. I'm going to check into that. That would be so much better, right, than this. It would be so cool. And my iPad's a touch screen. I would be so excited if that would work. I'm going to check into that, guys. That would be awesome. I think we can get a stylus for cheap. That should work. Okay, so this is 344.24 grams. You'd be able to see it so much better and just hear me talking. Be like the next Sal Khan. Jen Waker. No, I'm not nearly as smart as that man. So, okay, so what do we say? Two significant figures. So this can only be 658 fruit fly frying around here grams of calcium. No, only two. 660 grams of calcium. Only two significant figures. And then this one's going to be 340 grams of nitrogen. Okay? Does that make any sense? I sure hope so. I hope that was helpful. I'm really excited about the stylus and the screen recording because I feel like that's a little teeny bit hard to follow. But I would appreciate if you could do it, even if you numbered your steps like that, the 1, 2, 3, and just step by step, show me what you're doing. You don't have to write out in words what you're doing, but if I can just kind of see step by step what you're kind of thinking through to organize instead of just jumping all over with different equations, it would help. It might help organize your thinking too. So you figure out how much actually reacted, then you figure out what factor based on how much actually got made. What does that have to get multiplied by? So when it was like saying 1,000 kilograms of calcium nitride, here's calcium nitride. What did that have to get multiplied by to get to 1,000? And this is like a factor. Okay, it's just a factor. It's a dimensionless number. And then I multiplied that by each of my elements, but not 100 grams of nitrogen, right? Because that was not the exact amount. It was 52.5. And maybe if you even want to put that in parentheses up there to remind you when you go back that that's the amount that's getting multiplied by the factor, because that's the exact amount to get everything reacted without any leftovers. And that's how we wanted it. That's how they specified it. I hope that helps. If you don't understand these, work some extra problems in the extra help. And if you need more of them, I'll find you some more practice problems. I'm sure there's a never-ending supply of those on the internet that we can find, okay? That's that. Bye, guys. That's all I'm doing for tonight. If I do any more, it's probably bound to stop making sense. All right, good night.